Bismillahirrahmanirrahim. In this lecture, we have to discuss increasing, decreasing interval for a function or for a continuous function. To find the interval on which a function is increasing or decreasing, we have to follow the following steps. First, we have to uh, find. First, we have to find critical numbers. Critical numbers. These determine the boundaries of your intervals. Second, pick a random x values on each interval. Means we have to pick a random test value on each subintervals. Thirdly, determine the sign of the derivative on that intervals. Example, find the interval on which the function f of x is equal to x cube minus 3 by 2x square is increasing and decreasing. So critical numbers of the given function. Derivative of the given function f dash of x is equal to 3x square minus 3x because derivative of the first term x cube is equal to 3x square and derivative of minus 3 by 2x square is equal to minus 3x by using power rule. Now put first derivative is equal to 0. Now by taking 3x as common factor, which implies 3x into x minus 1 is equal to 0. Now this become, by solving this, we get x is equal to 0 and 1. So 0, 1 is the critical number. These critical numbers divide all real line on three subintervals from minus infinity to 0, from 0 to 1, and from 1 to infinity. Because critical numbers is responsible for boundaries point or boundary values of each subintervals. Now, by choosing test point on these subintervals, minus 1 is a test point belong to first subinterval, 1 over 2 is a subinterval belong to second subinterval, and 2 is a test point belong to third subintervals. Now we have to check the sign of first derivative on each test point. If f dash of minus 1 is equal to 6, f dash of 1 over 2 is equal to minus 3 by 4, and f dash at a point 2 is equal to 6. So clearly, uh, clearly, f of x is increasing on first subinterval and third subinterval. So, and f of x is decreasing on second subinterval 0, 1. Now, second example, the statement of this example is find the interval on which the function f of x is equal to x cube plus 3x square minus 9x is increasing and decreasing. Now for finding critical numbers, first we have to differentiate the given function. Now uh, derivative of x cube is equal to 3x square. Derivative of 3x square is equal to 6x. Similarly, derivative of minus 9x is equal to minus 9. Now, by putting first derivative is equal to 0, now this is quadratic equation. By solving this quadratic equation, by using midterm break method or factorization method, we get two critical numbers minus 3 and 1. These critical numbers divide all real line on 3 sub-interval from minus infinity to minus 3, from minus 3 to 1, and from 1 to infinity. Now, by choosing test point minus 4 on first subinterval, 0 is a test point belong to second subinterval, and 2 is a test point belong to third subinterval. Now, sign a first derivative at this test point. If first derivative at a point minus 4 is equal to 15, first derivative at a test point 0 is equal to minus 9, and first derivative at a point 2 is equal to 15. So clearly, uh, first derivative is positive in first subinterval, and derivative is positive in third subinterval. So in these subintervals, in first subinterval and third subinterval, function is increasing. And on the second subinterval, first derivative is less than 0, therefore function is decreasing on minus 3 to 1. Another example, find all interval on decrease, increase, decrease, and all relative extrema. Function is given f of x is equal to x square plus 8x plus 10. So clearly the given function is quadratic function. So the graph will be parabola. So derivative of we have derivative of this function is equal to 2x plus 8, because derivative of x square is equal to 2x, and derivative of 8x plus 10 is equal to 8. Now uh, put this derivative is equal to 0. So this is linear equation. Uh, we have we have x is equal to minus 4. So we find one critical numbers. This critical number divide all real line on two subinterval from minus infinity to minus 4 and from minus 4 to infinity. Now choosing choosing test point minus 5 belong to first subinterval, and 0 belong to second subinterval. So f dash of minus 5 becomes minus 5, and f dash of 0 is equal to 8. So clearly, function f is increasing on first subinterval from minus infinity to minus 4, and function f is decreasing on second subinterval from minus 4 to infinity. Conclusion, f is decreasing before minus 4, decreasing before minus 4, and increasing after minus 4. So this mean that function have function have relative minima at a point minus 4. Thank you so much for watching this video. Please subscribe the channel for more informative